Muted. All right, let's kick that off again. So, good afternoon, everybody. Phil over here at JitCat Cam. Welcome back to yet again another Workflow Wednesday with none other than your host, myself, Fusion Phil. As you guys are jumping in here and I'm seeing more and more you show up, again, as always, we have nothing but the best of problems, like me forgetting to unmute my microphone. Now, if you guys do have any audio problems at any time, video problems as well, as we all know, I am the master at screwing this up. Go ahead and let me know in chat. And as the video says, this week we're going to take a very high level approach to some porting. So if any of you out there saw any of my boring posts this week, aka boring out blocks, this is going to fit right in with that as well. You might learn a few things and see a couple of neat tricks along the way. Let's go ahead and switch screens and jump into this. So as you guys can see, I've already got my engine head inside of Fusion 360. Should I say Autodesk Fusion? That's an old habit that's going to take forever to die. But I've also already designed what would basically be the trough or the swing that's going to mount my machine, right? So from here, I'm going to start with the basics. As always, we're going to create our setup. I'm going to go ahead and pick what I need to define as not only my model right now, which is the cylinder head, but also my fixture in itself. That way, when we get into machine sim and collision avoidance, we can see both of those work to our advantage. As you guys will see here on my jig plate as well, we've actually machined out a large amount of that area, giving us plenty of clearance when we get into our 5-axis toolpath. Now, as you can see, machine of choice here, I'm going to go ahead and pull open the library. This is a UMC 1000P edition. This is designed specifically from Haas for porting. Now, once you get your machine set up, you guys know it's pretty easy to go in. We need to go ahead and define how we want this to set up. I'm going to go ahead and do a selected point, and I'm going to pull that right off of the radius on that trough, getting it down on my machine. And then if I needed to compensate left or right or anything like that, we could go ahead and plug that info in as well. Now, you're going to notice I may have skipped a little too fast here, but I've failed to set my WCS. Again, all of this stuff, very, very important as you get your first setups done inside of Fusion. And we have tons of great content on that. But as you can see, my stock is going to be in the way for the most part of what we're going to do today. So I'm going to go ahead and make that change as well. This is a little bit of a pro tip for some of you that if you just define your stock also as the cylinder, in this case, we are just testing 3D toolpaths, see our different outcomes as we work through this. So let's go ahead and start to dive into our toolpath. So there is a lot of options out there. Again, this is a full 5-axis machine, but we could, if you've never done something like this, jump in with the basic of basic tools, right? Let's say I'm just going to shoot straight for 3D contour. Now, for any of you out there, you know that I'm a big fan of hitting the OK button, but we're going to get some problems if we try to do so. Now, I am going to come back to this lollipop cutter. But let's go ahead and do my favorite, which is always a 1/2 inch of some variety. In this case, we have a lovely 1/2 inch ball, right? Now, based on that information, I'm going to start with 3-axis, and I'm going to do tool orientation to make life a little easier. So let's go ahead and go right off my exhaust flange. Now, we do need to flip that, as you can see down at the end. And then I need to define a boundary that I want to work with inside of, right? So again, as we could leave this as a stock silhouette, now that's going to give us a lot of a tool path. So I'm going to do a selected boundary. And then from there, we're going to allow the tool to sit on center. Again, let's just give this the bare minimum information to kick this off. Seeing more of you guys jump in chat. If you guys have any questions at any time, go ahead and throw them in chat and let me know as well. Hannibal's here, like always, #1 fan. Great to see you, buddy. Hopefully you guys can hear me all right. But as you're seeing, again, I started with nothing more than a simple 3D toolpath. Now, I can't see what's going on inside of this part, which leads me to show you guys one of my very first tips. When working on the inside, whether it be a lathe or even a mill type of part, we can always do a section analysis. Now, I'm going to pull this off the end of my part, and I'm going to drag it inwards until I get to about center of that port. Again, by highlighting my toolpath, my stock is now in the way, so we could get that turned off down here under stock visibility. As well, you could see here on the Windows machines, we could go ahead and hit F8 as well. But what we are looking at is nothing more than a full 3-axis toolpath down inside of that port, right? So again, we kept this as a fully functioning 3-axis only toolpath to get a toolpath where we want it on the part. That's usually the first problem a lot of people have. So from here, I'm going to go ahead and duplicate this toolpath because another version of this specific toolpath might be to start with now triggering our 5-axis motion. So again, we can turn on 5-axis. We are going to leave primary mode to vertical. Now, a lot of people always ask me about these different modes. Vertical means stay vertical until we start to hit our tool holder, and then we will start to tilt as we get further down inside of that port. From point to point, same as from curve to curve, it's very easy to split these up mentally into from and to. So this is what your tool is pointing to or what your tool is coming from. One could be a point, another could be a curve, and we might be able to throw up some examples here in a moment. So what I'm going to do is I'm going to leave it as basic as can be, and we're going to go ahead and hit OK. So it'll take a little longer to calculate. Again, it's a full 5-axis toolpath. As you're seeing, we are getting a ways down inside of that part, and it's going to look like nothing has changed between the two of these, and that's because for some reason we've gotten almost the exact same profile. So let's go in and make sure our shaft and holder is turned on. In this case, it is not. So what I'm going to do is we're going to jump back over to multi-axis and turn on collision avoidance automatic. Again, what that is going to do is give us shaft and holder based on that type of information. So again, we'll go ahead and hit OK and let this calculate. Hannibal, I see a question out there. Does the simulation incorporate the Haas? Haas, H-A-S, as in the machine Haas is what you're asking about? Go ahead and turn myself down a little bit. Looks like we're getting a little loud from time to time. Again, as that calculates out, I may adjust my first toolpath. Again, we could turn on shaft and holder and auto trim if we're getting too deep. Again, some tips and tricks here to get you guys started. So it does, and we're going to go ahead and simulate these toolpaths here in a second. So if I was to simulate this toolpath right here, I'm going to go ahead and give this a moment as it fires up. And then we will turn around and start to calculate some other toolpaths as we go. So again, we're going to give this a second here. Now we are in machine simulation. As you guys can see, I'm going to go ahead and turn that machine on. Now on the UMC edition for P, the 1000P, you're going to notice that this table is actually hard mounted. So you do not have a C axis down here on the table. What you are going to get is a B axis and an A axis tilt configuration. But now if we were to go in and start to simulate this toolpath, what you're going to notice, again, the table tilts up, we come over and in. Now, in my case, I believe my jig is hitting my table, as you guys can see, clear as day. That's why we got that first collision. But now I could start to run that toolpath. Again, as I stated, this is a full 3-axis only toolpath with shaft and holder turned on, which will allow us to auto trim if we get too deep. But the idea here is you guys can start this off with just about any and every toolpath. Now this one is taking a little longer than expected. Of course, our tolerance is cranked way up, so let's turn that down. And in the meantime, let's go ahead and shift gears because I could take another 3-axis strategy here and we can quickly swap that out into something like a ramp, which again, if you guys didn't know, a ramp is just contour, but we can machine constantly downwards in Z. We could also change out and swap over to something like possibly geodesic. But what I'm going to do here is we're going to go ahead now that our toolpath is calculated. You can see here, initially we only got so deep. And then the second time round with this toolpath, we've actually gotten much deeper. Now we didn't get deep enough in this case to get actually into undercutting, but we are going to go ahead and duplicate this one more time. And then I am going to pull up that lollipop cutter. Again, as you guys are going to see on this lollipop cutter, if I get moved out of the way, it is a mile-long cutter. Again, as you're going to be able to see, is we're going to get a lot more reach. And all I've done here so far is just used 3D contour, turned on multi-axis. And as you can see now, we are machining all the way down inside of our part. Now, some of you are probably going to question the fact of why are we getting additional toolpaths outside of here? And the reason for that, if we get analyze turned off here, is at some point it is able to plunge down outside of that boundary. Now, in this case, What's really funny about this is it's actually going to do a full 5-axis motion, get down and around and start to work back the opposite way, right? Now, keep in mind, based on what we defined in our actual boundaries, right? We said stay on center of this ring. And it just so happens that getting in through the bottom, as well as over here on the side, is still within that ring. So this is where we like to tell most people, you can now proceed down this list, possibly add in things like the ability to avoid certain surfaces. Again, I'm going to go through here, grab a couple of these surfaces just to get them so that we don't touch anything over there. Again, hitting OK, allowing our toolpath to recalculate. Now, I might actually use another technique, which a lot of people are unfamiliar with. As you can see, that cleaned up my problem with no issues. But I could have also, if I undo that, so I'm pushing Control Z on my keyboard, I could have also trimmed that, right? So again, in order to have 5-axis simultaneous or 4-axis simultaneous, you're going to need the machining extension. And this is where something as simple as the trim toolpath, we could go in and trim out specific areas of that toolpath. And as you're going to see here now, we should have gotten rid of that. Now, based on your view, will make all the difference here, because in this case, it doesn't look like it trimmed it out. So let's go ahead and fix that one more time. As you can see, that little rectangle I drew completely missed my part. So let's try this one more time at a little better angle. We're going to go ahead and redraw that profile. Maybe. Let's see what's going on here. So we're going to go ahead and do a polygon. And it looks like we would be better off just going in and deleting that trim and recreating that trim toolpath. So again, go ahead and trim. And what I'm seeing here is I think we've just discovered a bug where it's wanting to do something, but it's also not. Or, as always, yours truly is probably a little too far zoomed in. See what it should be doing. And as you guys can see, getting that boundary aligned here is being a little bit of a trick. Let's see if we can't get that now moved around. Be able to cut that. So again, as you're seeing, it is a little tricky here with trim and full 5-axis, which is why at the end of the day, you might be actually better off doing something like you guys saw me do with avoid touch machining, right? So again, we're going to go ahead and leave that for now, just so I don't have to keep messing around with it. But the whole idea here is to quickly go from 3-axis into 5-axis machining. As well, with that lollipop cutter, we also could have stayed in 3-axis mode. Again, as if I duplicate that initial 3-axis and we swap out to that lollipop cutter, what you're going to notice is even though that we're only in 3-axis mode, there is still calculation of undercutting and getting further down inside of that part. So again, we'll give that a second to calculate out. So that was a full 5-axis ball. This was a 3-axis ball. We have our 5-axis, as you can see here, with a lollipop. And then we're actually getting an error here. So let's go ahead and take an evaluation as to why. We do have shaft and holder turned on. We have our boundaries all set. Now, sometimes it is easier, as you guys can imagine, to go in and just recreate a toolpath from scratch. Again, I'm going to now jump into this toolpath here, and we can simulate this up. And then we're going to shift gears, because I think from a 3-axis standpoint, if any of you are out there doing porting, you're probably pretty much an expert inside of Fusion 360. Now, if you're not and looking to get trained up on that, we have plenty of times and plenty of free classes out there for anybody and everybody to use, as well as tons of different content on our website, as you can see here. We're machining down, and I guess I was a liar, because I believe we didn't do full 5-axis till there it goes. I am just a liar at the end of the day. Let's go ahead and fix machine simulation here. Not ideal that that trough is so big in size, but let's go ahead and get that moved up. Again, we're spinning around center, so we could get a little bit off of center as well. And upon moving off of center, that will allow our machine simulation to go ahead and create those toolpaths without any type of collision or issue. So again, we'll give this a second to calculate up. Get spun back around here. And let's go ahead and hit play. Again, keep in mind, we do have vertical turned on for our actual collision detection. We're not using 2-point, from point, anything like that. And as you guys can see, we're now starting to rock around inside that machine. And she's doing a little dance as it works further and further down. as much as it can avoid and clearance inside of that hole. So again, very neat thing to be able to quickly go in and create some porting toolpaths. Again, working further and further down as much as we can reach with that tool. Now, I'm going to give this a few more minutes because I believe it is going to retract and we are going to get a collision. And we could, of course, fix that. But it's coming up down here on our timeline. We'll give it a few more seconds. We'll speed it up just a little bit to get there. And then as you guys saw, it just came out and it flipped over. And now it's doing that weird area from that second port that it could get into. And now we do have a collision here. And that collision is on that retract. Again, we're going to flip back around. Looks like we're going to get back down in that main cavity. Continuing to work some more. So in the meantime, as you can see, we get further and further down. Again, based on that boundary from our view, you're noticing that it's only machining one side of that port. We're going to go ahead and get up, out, flip around, and one little nub down there at the bottom. So let's change gears here. Let's now look at a few other toolpaths that might work much better for what we're doing. So again, if you ever have questions about what toolpath might be best for your situation, in this case, we are doing porting. There is no porting tool inside of Fusion, of course, but we can make do with some other things. But if you're ever looking at a toolpath and you're like, you know what, maybe Geodesic will do something like this for me, is inside of Geodesic, if you look at your passes tab, is if it is basing something on either step over or step down, that is the difference, right? A step over toolpath is meant for more shallow areas, where a step down toolpath is meant for walls. Porting is more of a wall expertise type of situation. So I'm going to go ahead and swap that out and let's go to steep and shallow. Again, steep and shallow, I feel like is still a new toolpath to me because it combines a lot of great things. And we did start this all off with the concept of 3D contour. Steep and shallow does about the same type of work. However, we're going to have some fancy things we could do here. So again, we do our tool orientation off of our face. Go ahead and get flipped the other way. Again, let's go ahead and give this a selected boundary. Again, we just want to stay within this area. Now, if you guys are doing this all day, every day, that boundary is going to change, bigger, smaller, using surfaces. And I'm going to show you some tricks on surfaces here to make your life much easier. So as you can see, again, heights tab, no changes. In passes, this is where the magic happens. Now, steep and shallow is kind of an exception to the rule because you have a step down as well as a step over. Now, again, a port doesn't necessarily have a shallow floor area. So what we could do is we could actually tell this toolpath only do the steep areas, which now forces steep and shallow to only do the walls more or less. Again, we can control our step down. We also now have the ability to do machine undercuts with a ball end mill type of tool. So again, we go ahead and leave this pretty standard here. Steep and shallow from Z, 3-axis only. We'll go ahead and swap that out to 5-axis once we get a toolpath on our part. So again, you saw me fail miserably earlier with contour, not the biggest deal. Now our steep and shallow is going to make up for that because as you guys are going to see, that lollipop cutter is going to get underneath everything that we have going on here, right? So again, based on the relief of our ball versus our tool holder. Now this is very critical at the end of the day because I did allude to this, but you do have shaft and holder. Again, you can adjust your shaft and holder, or if you're like me, you know what? Those blue lines are 80% of the way there. We can now hot swap out to our 5-axis. Again, you still have your 5 standard ways, vertical, to's and froms, points, and curves. Now, we have a different one called lean and lean. Now, what we could do is we could either lead, which means tilt the tool forward or backwards to get off to the 0, as I've heard it, 0 RPM or the tip of the tool. Or we can actually do what's called a lean, meaning lean in or lean out from what we want. Now, keep in mind, if you pay attention here, I know a lot of people have asked me about this, is if you have a lean angle of 0, your tool is perpendicular to your surface. So keep that in mind. In most cases, you're going to want something like a negative lean, as you're seeing in that bottom right corner, right behind my head here, as I'm seeing. But just like that, again, we could go ahead and set this up. We could give it a little bit of lean, or we could leave it at the standard vertical toolpath. Now, with that, I see Angel out there in the chat. Won't it affect the valve guide, or is the path outer part of the tool? The part is the outer part of the tool. So from that, we're going to go ahead and visit those questions right there because, again, you're right. That is a valve guide right there. We haven't quite covered our surfacing side of things yet inside the software. But as you guys have just seen, I did a vertical toolpath. Now, this could cause us some problems because we are limited due to our boundary on how far we can get around inside that port. But if I was to simulate this right now, I'm going to be more than sure we're not going to see any tilt until we get way down on the neck of that tool. So before I move any further, what I'm going to now do is we're going to shift gears and we're going to create a couple of surfaces here to make life nice and easy. So would increasing the lollipop diameter help with undercuts? Yes, 100%. So the bigger the tip of that actual tool is, or the smaller the shank, the more undercutting you can get away with. So let's go back to design. Now, a couple of tricks here, and some of you guys have seen these in my videos or my free support Fridays, is the ability to go to surface and do some simpler type surface stuff. So we've already seen it where it's trying to get inside of this port here when it flips over. Now, I could simply just create a patch and utilize that patch as part of my toolpath model to keep it away from there. So again, what I'm going to do is we're going to go ahead and hit OK. I'm going to right click repeat patch. So again, if you wanted to, you could go back to the toolbar or top. Again, maybe I patch off the entire exhaust port. Now, another thing I'm going to show you guys, this is very handy, is the ability to do what's called an offset surface. Now, what an offset surface will do is allow you to take, as you can see here, the inside surface of this actual port. Now, I'm going to do this based on an offset of 0. So let's go ahead and get flipped over here. Grab some of our surfaces all the way down. And what that is now, as I like to say, the snake skin or a copy of all of those actual modeled surfaces. So this will take a second to calculate. Again, as you guys will see here, if I go over into my body section, if I turn off my main body, you can now see I have this perfect replica of that port. Now, if you are somebody out there dealing with a 3D scan versus the original model, again, you might have a skin of what you're actually trying to port the OEM ports out to. So again, what I'm going to do now, though, is I do have this big gaping hole here. We can simply go in and patch that up as well. So as that question was from Hannibal, or not Hannibal, but Angel, being able to avoid that actual valve seat or that valve guide, I've now patched over that, and we can use that patch to my advantage. So again, we shift gears back to manufacturer as always. Now I'm going to click this dot at the top. You guys are going to see it's going to kick everything back on and off as needed. Again, let's go ahead and get rid of that toolpath out of there so we stop having our errors. Now, again, if we go to that toolpath in particular, as you guys can see on that 3D contour, you saw me struggle pretty good with trying to trim that out of the way. But this is where I could go in, geometry, model. I still want my setup model, but I am now going to include my additional surfaces, right? So again, I know that I created those couple of surfaces to patch in those holes. You guys are going to see I can turn those on to see them. I will need to turn off my analyze because as you can see, I've grabbed them from my design tree, but by having them on in my part, they are now considered part of my actual manufactured model. So again, upon hitting OK, now we're going to go ahead and turn them off and we're going to get our analyze back on so that we can see our toolpath. And just like that, you're noticing we're no longer jumping out and around that toolpath to do any additional machining in the port we didn't want to touch to start with. So what that allows us to do is now we could open up our boundary. Maybe we go tool outside of boundary. Again, hitting OK. We're going to see that toolpath start to get further and further down in that port. I assume we're also going to see some more work coming from the second operation, which is tilting around automatically. So again, as you guys can see, something as simple as surfaces, we're now getting additional things on top. We could, of course, go in, avoid surfaces. We're also getting more things outside of that. This is where you start to play the game of what do you want to keep, what don't you want to keep, to get your toolpath where you want it. Now, what I'm going to advise is if you are doing something like porting, this is where I think for most of you, switching gears to a toolpath that is driven by surfaces and not by boundaries is going to be night and day difference. So if I go to multi-axis finishing, what you're going to notice is one, this is a full 5-axis toolpath only. However, this toolpath is driven based on, as we've talked about, a floors versus walls scenario. Now, leading up to this, everything we've told the software is, do I want a machine on the floors or do I want a machine on the walls? Well, in this case, we want a machine down the walls to the floors or from the floors. And you guys are going to see how this works. So again, we could do one versus the other. We're going to go ahead and machine the walls here. Now I can change my type of path. So we could say blend. So if you haven't seen a blend toolpath, we can go back to 3D at any time. Because you guys, we're going to blend the top and bottom. Again, we just want to chase around that port, staying in kind of a circular motion, not a vertical motion if we don't have to. So now what is going to be my floors? So some of you out there may say, my floor could be either the deck of my port, which you're not wrong. And if you guys see me select down here, this bottom surface, my arrow is pointing up because we want the toolpath to start above the arrow and use that as our bottom height. Or I could actually start off the flange, considering I'm going to come in from that flange and flip it the opposite direction. So as you guys are going to see here, let's go ahead. We have our lollipop cutter. We're going to go in for our floor surfaces. Now I do need to define my walls, but this is why I showed you guys how to do an offset surface, right? So with that is, if I go to my lovely offset surface here on the left, I can easily pop that out. Again, let's get our model out of the way. And this is now what I'm going to select for my machining. As you guys can see, between having the analyze on, the ability to only work with the surface that I'm looking at, it makes my life a dream if that's what I'm going to utilize for machining, right? So again, let's go ahead and get these all picked out here, all the way down to the bottom. And then I'm going to go ahead and turn that analyze back off. As some of you are probably questioning to yourself, you'll have to let me know in chat that, hey, all those years that I had to like tilt around and zoom all the way down to pick things, Fusion Fill here has just showed me how to do it with an offset surface. One more thing we are going to need here too, guys, that patch, of course. We will add that patch in now to our model. And as you can see, we've basically said nothing more than we want to use this surface as the floor. And we want to machine these walls. And then, of course, we want to include our patch. Now, for some of you, you may be questioning why I add the patch at the toolpath. Well, in a perfect world, you're probably going to drill, ream, or those bushings that are going to get pressed in there anyways. And that patch would get in your way later, again, causing problems. So I only need it on this one specific use case. So again, for the sake of this video, we're going to go ahead and change our tolerance down to 4/10 or 4 thou, speed up our toolpath calculation. We're going to do a pretty big step down as well. It's more important to get those blue lines on the part as always. Mateus, I see you out there saying hello. How's it going, buddy? Will be good if they add something to select somehow faster and easier. I'm in full agreement with you. Now, I've seen some pretty interesting things that we could always test out here to create those selection processes a little quicker. Now, how you could do that, as Mateus is asking, is if I go ahead and right click and create a selection set. So that selection set is now everything inside that port, right? Is if I was to recreate that toolpath, we're going to let that one calculate here. Let's go multi-axis finishing. And let's say I wanted to pick these walls. Now, if I go in and I try to use that selection set, it's not quite working as I would intend. Now, it does work quite well outside of that. If you're going to do something like avoid machining, you should be able to quickly grab everything in one shot, right? Now, I'm going to go back and visit this a little bit different. Because again, you have walls, you have floors, but if you guys notice over here, there's now an entire section for floors. So if you double click that, as you can see, it's only giving me the option to edit this. This is where, as Mateus is saying, I would really like to see Autodesk allow me to selection set multiple walls at the minimum, right? So again, is the ability to go in and quickly define, hey, you know what? I also want to add in my patch. And with that, I can update and grab everything in one shot anytime I go to my selection set. But on certain toolpath areas, I can't select them all in one quick motion, right? So again, as you guys are seeing here now, we have our lovely multi-axis toolpath. And what it is doing, again, fancy move here, we turn our analyze back on, is we are working both ways through that part, be able to machine all the way down and in from both ends, creating that different type of strategy. And again, because we are blending, you're going to notice that it's kind of fanning, right? Almost like a center point to follow around that curve. So let's go ahead and simulate this. I see a couple more questions coming in, of course. Oh, in this case, tool orientation is not supported for available machine. As you guys can see, this specific machine cannot tilt to actually successfully complete this. This is the importance, and this is why I always love to hit you guys with something, right? Is, of course, you can support our channel, which my lovely face is not on. There we go. As you're going to see here is with that information is you guys have that ability to buy a support package from us. We include editing stuff like this. We have videos on how to edit this and get around it. You can also buy me beers and steaks if you guys thoroughly enjoyed this content. But as you're going to be able to see is we can now go back and either we need to fix what the toolpath is doing, or if we know our machine can do it, we need to edit what the machine capabilities are. So in this case, I don't think we're asking too much of the machine. But let's go ahead and edit the machine real quick and see what our limits are set to. Now, there will be a limit in our B-axis tilt. So again, in our kinematics tree, as you can see, we can only tilt negative 45, positive 45. Now, on our A-axis, we have unlimited. So some of you may have to confirm this for me. Google search it real quick. Does Haas's UMC P allow for us to do more additional tilting than what's needed? I'm also realizing it looks like my green screen's a little messed up in the background here. Give me one sec here. Go ahead and fix my green. There we go. And we should be back. All right, I see what happened. So my window blinds are open and the sun's coming in and hit my green screen. But again, as you guys can see, our B-axis limit is 45. So what we might need to do at the end of the day is go into our toolpath in the same thing. So again, as you guys are going to notice, and I always get this question is, why does it take so long to program a part? And well, the funny thing about that is you spend more time troubleshooting all this other unnecessary stuff. It's not usually just a point and click. We do teach a point and click, as you guys have seen, but now we could go in again, multi-axis, dual axis limits. What is our minimum tilt angle? What is our maximum tilt angle? Where are we providing that from? So forth and so on, right? So again, as you guys can see, we're going to go ahead and hit 45 degrees is our maximum tilt. And let's see if we can get this to spit out a lovely simulation. So we have a bug. Do you see a bug? Oh, the bug with the Herco 42 SRTI. So I would need to see that machine model, but Mateus, that would be a great thing to send over for our free support Friday that you guys should be able to come check out. So a few other toolpaths we could look at on this part. Again, nothing is right or wrong here for most cases. You do have a blend strategy. Now keep in mind, blend is usually at this form meant for external corners. However, you do still have that ability to go in. Again, drive your toolpath from surfaces, which is usually the key element when you're dealing with porting. So again, we could go ahead and drive with surfaces. Now, can we select those surfaces from a selection set? Of course we can. Now, we do need to give this drive curves. Now, this is the thing that anybody watches my videos, I always get this wrong. But let's just say my drive curve is along the part. So let's go ahead and give it a drive curve along the part. Now, we are getting a red line, which is always lovely. I'm going to assume it's going to tell me incorrect number, select at least 2. So even if you at the bare minimum are giving it completely the wrong information as yours truly is doing, it does allow you to go back and redefine that. So let's go ahead and give this a second drive curve on the left. And we're going to find out real quick if I'm the wrong way or if I'm the right way. Now, our multi-axis contour toolpath, go ahead and get some stuff turned on and turned off. As you're seeing is we actually got a aired out toolpath altogether. And I'm not even getting a toolpath. So we might be pretty far down in the rabbit hole where this guy is just not wanting to calculate. So again, we're going to go ahead and set our maximum tilt angle back to 90. Now let's do this from a tool orientation. So again, this is the neat thing about multi-axis finishing is we could of course give this tool orientation. as you're going to see, just like we started out with, Z-axis a specific way. Then we can limit our tilt from the tool orientation of only going to a maximum of 90. And same thing as before, you do have that ability to lead and contact point tool accesses and everything and anything your little heart could desire, right? So again, we're going to go ahead and kick off that toolpath. In the meantime, I'm going to assume I picked the wrong curves. Let's go ahead and edit that toolpath one more time. And let's go ahead and select. We want that guy and that guy. Again, our drive curves in this case, let's go ahead and give it an upper and a lower drive curve. See what we get this time around. So outside of that, as you guys are seeing, is what we're waiting on now is nothing more than processing power of the software to determine the best abilities in the toolpath. But when it comes to going inside of these cavities and starting to create those different strategies, as you guys have seen, is it could be something very simple or it could be something very complex. But for most of you, you've noticed that I'm spending a lot of my time more in configuring the multi-axis area once I get the boundaries set on my part, of course. So again, I need to drive it, whether it be boundaries or surfaces, but doing that based on 3-axis and then swapping out to 5-axis makes this relatively easy. So I see Mateus out there. Calculation of toolpaths are still so slow. I mean, I'm not going to say it's something slow at the end of the day. You guys are seeing here, I think I got my floor direction off. You guys got me all caught up when I was setting up this toolpath. We're going to go ahead and flip that floor the other direction and recalculate it. Now, I do want to point out for a lot of you out there is if you are having slow calculations, now I've heard this from a lot of people. They're like, wow, your computer calculates fast. Yes, I'm on some of the latest and greatest technology, but I will say toolpaths are still a straight line. So single core processing speed actually overrides the number of cores when it comes to calculating. So we'll give this a few more minutes to wrap up. In the meantime, while that loads, why don't I hit you guys with the old upcoming events? In this case, I can't hit you with the upcoming events because I changed my button layout. So if you guys are still interested in getting any training hours or support from us, as well as buying a commercial license of Fusion, it's still 30% off right now until, I think Friday's the 1st, right? So a couple more days left to get in on that as well. Don't forget to come check us out when we're in Minneapolis or out in the San Francisco Bay Area for our up-and-coming free support, or not free support, Fusion boot camps, where it is free training each and every one of you, and you guys can get signed up via our website. So I did get my toolpath back up here, so let me get my screen share. Obviously, I am doing something wrong more than anything. So again, as you guys can see, based on our tool orientation, we want to do the walls. We could add guide curves if we wanted, our floor surface. As you guys are noticing, I'm walking through this just to make sure I have everything in the correct order. But what is very funny to me is that it is not respecting tool orientation Z, and it's still trying to machine upside down. So this is, again, one of those things based on your machine and your limits or what you're going to plug in may or may not make all the difference at the end of the day. So guys, I hope this helps you out. Again, I wanted a very high level of something like this. I didn't want to bore you guys too much, get too deep in the weeds. If you want me to get much more specific on porting, or there's something very in particular that you want to see, as always, feel free to hit us up down below. It's not what you know, it's who you know, and you guys all know yours truly over here at JitCAD. We're here to help you any way we can. Again, use the info email address down below. Send us your info. Let us know how we're doing. And if my audio sucks, I'll never get old. They'll always make me laugh when I see those comments. Thanks, guys. Have a great rest of your day.